So this is a continuation of the first part of the 2BI segment, where we're now tackling part I, where we're asked to draw all the possible collapse mechanisms. This was 7 marks, similar to the previous question. So to work out possible collapse mechanisms, it's best to first work out the indeterminacy of the structure. So indeterminacy is calculated by using the following equation, which is R minus 3 minus G. Now, where R is the number of reaction forces, 3 is the number of equilibrium equations, and G is equal to the number of joints. Now, R in this case is going to be, there's going to be one reaction force here, another reaction force here, and 3 reaction forces here. So in total that is equal to 5 reaction forces. So you have 5 reaction forces minus 3, and number of joints. So number of joints is simply the number of hinges within the structure, and there's 0 hinges, so that's going to be minus 0, and that gives an indeterminacy of 2. Now this allows you to calculate the number of hinges that will be required to make this mechanism collapse. So the maximum number of hinges that's required to make this mechanism collapse. So this equation is simply the DOI, which is what this is equal to. So DOI, degree of indeterminacy. So to calculate the number of hinges, the maximum number of hinges required for collapse, it's going to be DOI plus 1, and this is simply going to be equal to, so this is the number of hinges for collapse. So that's simply going to be equal to 2 plus 1, which is equal to 3. So you need a maximum of 3 hinges for collapse. Now we have to draw all the possible collapse mechanisms. So let's look at this section. So we now have, when it comes to beams, the best way, what you can do is you split them. You split the beam among with the reaction where the supports are. So there's a support here. So let me just highlight it. So support here, support here, support here. So you can separate them between the supports. So if you also split it into this section and this section, so consider all of this section and as one part of the beam, and consider this section as one part of the beam, as this is between 2 supports and these are between 2 supports. So let me just, now I might just leave it here. So we're splitting it amongst this. So when we're considering this side, we have to think about where we can add the hinges. So we have a maximum of 3 hinges we can use for collapse. Now what we can do is we can add a hinge. We can add a hinge at one of the forces that's acting on the beam, and at one of the supports. Now we can't add a hinge here the way I'm drawing it here, because this is at a free end and this is a pin support, so we can't add it there. We can either add it at the 2 forces acting on the beam, and we could add it to this part of the support, but remember we can only add a maximum of 3. So we can add it here, and we have an option between here and here, so therefore we'll go for one option acting here. So let's draw that. So we've added 2 hinges and it's basically failed. So now let's do the opposite one. So let's now do it at the 1.5 W load. Let's draw them up. Yep. And let's do it. Let's consider the other side now. So the other side would be here. So this is the other side of the beam. Now in this case, since this is a rigid support, you can add a pin here because it's not a pin support. So we can add a pin here. We can add another pin here. And we can add a pin where the force is acting. So we can add another pin somewhere here. And we join the two here. Now as you can see, each of those sections has created a displacement. So let's just write down the displacement. So displacement of let's call it displacement 1, and obviously each of these displacements are so like the delta 1 and this delta 1 are different delta 1s, not the same, but otherwise I'll have many deltas, so I'm just gonna repeat the two. So delta 2 and for this one we will have one delta. So these displacements are only under where the loads are acting. So where the loads are acting, you have to show the displacements at these points. So I'm also going to add the angles that these loads create. So I might denote that in a different color. So here we have alpha, let's call it alpha, theta, and this here, let's call it beta. Same for these ones. Okay, and we've drawn 3 collapse mechanisms, and this will be it for this part of the video, and we'll continue doing part III in the next tutorial.